Hello everyone, welcome to the full Python course for solo beginners. In this course, I'm going to be walking you through all you need to know to learn Python programming as a beginner. Right now, I have an IDE set up, which is one of the most popular IDE, which is Visual Studio Code. To download Visual Studio Code, all you need to do is to go to your browser and type in Visual Studio Code download on your browser. Okay? Um, and you're going to see this link here where you can click to download for either Windows or Mac or any other operating systems that you use. Okay. So once you have Visual Studio Code downloaded, you're going to be presented with this interface when you open a folder. So I have this folder here that I'll be using for this course. I've already created a Python file called apps.py. Python files have an extension of .py. Now, to be able to actually write Python code and run Python codes, you need to also download Python from your browser. So you can just go to this link here, python.org/downloads, and download the latest version of Python and install it. Then you also come to your extensions panel on Visual Studio Code and install Python. You search for Python, you can see this very first one here, and you install it. So this will give us the full access to one Python programs on Visual Studio Code. So once you have all of that installed, then you'll be good to go to start writing Python code. So what I'm going to do is to open up a terminal so that I can see the results when I run my Python codes. All right. So as I said earlier, I have this Python file called app.py. I'll be writing my Python codes inside this file. I'll be running it using this button here, and you'll see the outputs below. Okay, so the very first thing you need to learn about Python or about basically any programming language is something referred to as variables. Before we even proceed to variables, why we learn programming languages? What's the meaning of programming languages? Because as I said, this is for absolute beginners. Programming languages is basically a way that programmers communicate with the computer to do something for them, right? Because we know that computers have this incredible ability to do stuff faster and to compute things at a very high speed and so on and so forth. So they basically have some abilities that we human beings don't have. And computers have the ability to do the same thing over and over and over again. So why not just write a program for them and tell them to keep on doing that thing as long as they exist? All right, so that's the advantage that computers have. So programming languages basically give us that power to be able to write programs for the computer to use and to keep executing for as long as they exist. All right. So that's it. So Python programming is probably right now the most popular programming language that's there. The other programming languages like C Sharp, Java, JavaScript, Kotlin, and the rest. But Python programming is very clean and very popular because of its usage in machine learning, its usage in web development, and so many other areas. Okay, so what you learn, as I said in this course, is it's the very, very, very foundation, right? So if you have no experience with Python programming, you're welcome. So let's start coding. As I said, the very first thing you need to learn is variables. So what are variables? So we're going to be using this. I need to change this to the UX. Right. So I'm going to use something referred to as a comment to be able to break down the blocks of code I'll be writing in this script so that it is more cleaner and easy to understand. So in Python, there are two types of comments. We have the inline comment and the multi-line comment. So what I've just written now is an inline comment. Basically, what a comment is a comment is basically a code that you won't call it a code because computer doesn't execute it, but it's something that a programmer writes in his script or in a in a programming file that is not executed by the interpreter. In this case, the Python interpreter, right? So it is basically for the programmer itself. So that's basically what it commented. So in Python, there are two types. There's the inline comment and there's a multi-line. So this is an inline comment because if I go to the next line, whatever I write here is no longer a comment. So I need to write another hash here to make it a comment. If I wanted to write multiple lines of comments, what I need to do is to use this, my quotes, and once I write 3 quotes, Python, the program language is going to help me complete that by writing the ending quotes. So this 3 single quotes and at the start and 3 single quotes at the end. Everything I write here is going to be a comment. So it can span multiple lines. And when I execute this script, nothing's going to show because this is basically something that is meant for the programmer itself. All right, so I'm going to delete these multiple lines of comments. So for those of us who may be asking, the spelling for single line comments is this. This is single line, and this is multi-line. So now let's learn about variables. So at the foundation of writing programming languages is learning what variables are. Variables are basically containers. Because you're giving instructions to the computer, you need a way to be able to hold data so that you can pass information that you want to pass to the computer and tell it what to use that data to do. So, as I said, variables are just basically containers. And in Python, to create a variable is very, very easy. All you need to do is to give the variable a name. I'm going to give the variable a name of number or just num. Now assign a value to that variable. So this is how to create a variable in Python. Right, in this case, our variable has a name of num. Then there's an equal sign, which is referred to as the assignment operator, and the value we want to store in that variable, which is 6. Now, to confirm that this value has been stored in that variable, you're going to use the print statement and then pass in the variable inside that parenthesis. Now, if we execute this code, you notice that we have a value of 6 here, showing us that indeed that value is stored in that variable. Now, there are different types of values you can store in a variable, which I'm going to be discussing next. But I want to mention something as to why Python is different from other programming languages. In this particular code, we wrote the variable name and then the value. We did not tell the programming language that this is the type of value we want to store. In Python, you don't need to specify what type of value you want to store inside a variable because Python is a dynamic programming language. It infers the type of data that you would store by the value that you specify. Okay, so in this case here, by seeing the numeric value 6, it infers that the data you want to store is indeed an integer. Alright, so as I said, you can store various type of values. You can store integers, you can store floats, you can store booleans and the rest. So that's what we're going to discuss now. So let's talk about the something referred to as data types. So what are the different types of values you can store? Right. So we're going to be talking about primitive data types. That is the data types that are owned by the programming language. So at the very top is, let's learn about integers. So we've already seen an integer earlier on. So to store an integer, all you need to do is just to assign a value of an integer to that variable, right? And these integers are basically whole numbers. So we're going to print out this value of x, and we're going to also print out the type. So we're going to use a type function and passing our variable inside that type function so that Python shows us what type of value are we storing in that variable. So I'm going to kind of highlight this and press Ctrl/ to comment out that backlog of code because I only want to see these two type of codes. Then I'm going to run this. So you can see that I have the value of 10 from this particular print statement, and I have a class of ints here printed for me, showing me that indeed this variable stores a value that is of type integer. All right. So let's look at another data type. In this case here, I'm going to talk about the string data type. All right. So if you want to store a combination of characters in Python, you use single quote or double quote. So let's say I want to store the name of someone. I can just basically give the variable a name, and then what I want to store as that name is, let's say, John. So I can either do this or I can do this. So I'm going to have a variable of first name. And all right, so I'm going to print name, print first name, and I'm also going to print the type of name. And I'll also print the type of first name. All right. So I'm going to highlight this code and then use Ctrl/ on my Windows laptop to comment it out because I don't want that to run. So I'm going to run this now. So as you can see, I have John, 10, and then a class of string. So they are both classes of string. Meaning that you can write strings using single quotes or double quotes. Now, there's something you will notice when I created this second variable for this particular string. I use an underscore. In Python, when creating variables that have multiple words, we separate them with an underscore. That is the convention in Python. In other programming languages, there is a different style to the way they name their variable. When in Python, we use an underscore to separate the words. All right. So this is what is referred to as snake case, and is how most Python programmers name their variables. All right. So that's a string. Now there's another data type referred to as float. The floating data types are just basically numeric data types that are decimals, right? So let's say I want to store the price of something. And that's going to be decimal. Print out price. Print out the type. See that. Let me highlight this one. Okay. Just comment this one out. So you see that indeed it's self-type float. So if you're storing numeric data types, the numeric data types that are decimals, what you're actually storing is a data of type float. Okay, so you can also store something referred to as booleans. Okay, so whenever you're storing values that are either true or false, you refer to them as booleans. So let's say I want to store I want to store a value of whether it's raining or not. So I'll just use the variable called it's raining. So here I'm storing the value true inside that variable. I print out it's raining, and I print out the type of it's raining. And so I run this code now. You see that I have true for is raining, and I have a class of bool for the type. All right. So so those are the basic um the primitive data types that you will find, right? Um, okay, now that we have an idea of some of the data types for variables the values that we store in variables, there's something that you need to know, and which is that you can actually convert one data type to another data type. Usually, when you write a program, you have to make that program available in the form of maybe a website or a mobile application. And the data that's entered into the inputs on those devices, on those softwares, is usually a string. So you may want to, and if you want to manipulate that value that is stored inside the string as a number, you may want to actually cast that value or convert that value from string to a number first and do the calculations and then use that and then send back the results. So let's assume I have this I have a number. So let me create a let me so this is what I refer to as typecasting, right? So I have this number which is actually so you can see storing a value of 34, which is actually a string inside a variable factored number. If I try to add, so I can I want to do something called num gross. So let's say I want to add a value of 12 to this string, right? So what am I going to have? So I'm going to have an error here. As you can see, the error is on this line. And the error statement is you cannot concatenate string to not int to string, right? Because what Python is trying is how Python is interpreting this code is that I'm trying to concatenate two strings. However, this value of 12 is not a string. Okay, so how do I avoid these issues? The first thing I have to do is to come in here and say um, I will convert this num into an integer by passing the value of num inside the int constructor. Right? So all data types have their constructors. So this is basically the int constructor, right? The constructors for strings are is the str. Then we have constructors for floats, constructors for booleans as well, right? So if you want to do a cast from one data type to another data type, you use this constructor. Now in this case, I'm passing the variable I was created here inside the parentheses of that constructor. So what it's going to do is to convert that value of 34 that is stored in the variable from a string to an integer, and then reassign that value to that same variable. So this is what is referred to as variable reassignment, right? Because the variable I've created here, and I'm basically reassigning that the new value that is on the right hand side to that same variable. All right. So now if I run this code, I should not have issues. As you can see, my result is 46 because 34 plus 12 is indeed 46. Right, so that is typecasting. Um, so you, you should be aware that you cannot do conversion for all kinds of um, all kinds of values. Like for instance, if my string is not a numeric value, if it's a combination of characters, if I try to convert it from a string to an integer, I'm going to have an error. Right? The same applies to some other data types. So you just need to be aware of what you can convert and what you can make about. But the idea here is you can actually cast one data type to another data type to further manipulate the data that's stored in that frame. Okay, so uh, apart from this very basic data types, there are other data types which I'm going to discuss, which are sequence data types. Okay, so but before we proceed, I want you to be aware of something, which is that variables are actually scoped, right? When we discuss something like functions, I'm going to explain further as to something referred to as variable scoping. Okay, not all variables that are declared in a particular block of code, but define how the variable can be used and where the variable can be used. So, as I said, I'm going to explain more about that when we talk about variable scope. All right, for now, let's talk about the sequence data type that exists in Python. All right, so far we've just been seeing some very simple data types like numbers, integers, floats, booleans, and um, strings. All right. So, what if I want to store a combination of the numbers? Right. Let's say I want to store the scores of all my students. Right. I can't store that in an integer. Right. So I need a way to like have that data right in one place. So to do that, I need to use a sequence data type, and there are a couple of them. So we're going to start with the list data type. Right, so the list. So how do you create a list in Python? All you need to do is just to give the variable a name. So in this case, I have let's store scores of student. Rather. So this is my variable is called name. So scores rather, and then I have my equal sign operator, which is the assignment operator. Then I have my square bracket, right? So inside the square bracket, I'm going to write different scores. 4, 10, 3, 10. All right. So basically, this variable is storing this sequence of numbers, and if I print out this variable scores and I print out the type of the variable, we're going to see that indeed it is a list. All right. So you can see that is indeed a list, right? So that's how to create a list, right? So there are various ways you can manipulate a list to retrieve the values that are stored in that list, right? So, and there's something you should be aware of about lists, right? And that is that list is an ordered data type, all right? So ordered means that it's the values that are stored in that list have a specific position, and you can use the position of the values to retrieve that particular value. So let me show you what I mean. So for instance, I have the value of 23 as the first position, right? So if I want to retrieve that value, all I need to do is to use the index of that value. And in Python, the very first value for any sequence has an index of 0, right? And the next value has an index of 1, next value has an index of 2, and so on and so forth, and just like that, right? So if I run this code, you see that I have the value of 23, showing that I've been able to actually I've been able to get the first value from this sequence, right? So in Python, you can start counting your index from the start or from the end, right? So if I'm counting from the end, I'm going to start with the value of -1, right? So if I run this code, I should get the value 10. As you can see, I have the value 10. So that means this is going to be, this 23 here is going to have an index of -2, and so on and so forth, right? So this is what makes the list data type to be a mutable data type, all right? So let's discuss the other sequence data types as well. So there are other ways you can manipulate a list as well, but we are limiting this class to the very basics. I want to cover all the basics that you need to know so that you can start writing your own Python code. So let's talk about tuples, right? Right. So tuple is just basically a sequence data type that you create um, in this form. So let's say I want to create a sequence of names, Let's say, so John James, right? So you notice that in this tuple, I have these names like this, you can see, and if I print out, so difference between tuples and lists, as you can see, I am starting this with a parenthesis. In a list, I started this with a square bracket, all right? So, and I print out the type names. You see that I have this, and I have the class of tuple here, showing me that indeed this sequence is of type tuple, all right? So, um, the thing about tuples is that tuples are not mutable, all right? When you create a list, you can actually mutate that list, right? And what mutation means is that mutation means you can change the values that are stored in that list. So let's say for instance, I want to add a new value to the list I created here, all right? So all I need to do is actually just to come here and say scores to append. So there are various methods for mutation. So if I press this dot sign on that particular variable, I can see that I have a couple of methods that are available to that particular data type. So we have the append method, the clear method, copy method, the extend, the count, index, the pop. So this pop is a mutation method, meaning that it's something that mutates the data that is stored in that variable. So the remove method to remove and the rest, right? So let's use the append method and assign a value of 56, right? So what it's going to do is basically going to append the value of 56 to this list. And if I check, I'll see that I now have a new value of 56 to that list, all right? So, but when you try to do the same for a tuple, you see that you don't have such methods available to a tuple because a tuple is designed not to be mutable. All right, you should not be able to mutate a tuple. Okay, so that's the difference between a tuple and a list. Now you can also um, get out. You can also index a tuple. At least you can retrieve the values that are stored in a tuple using its index, showing that tuples are actually ordered just like lists. Right? So that is the similarity between a tuple and a list. So let's say I want to print out the very first name in this tuple. What I need to do is to write out the variable that stores the tuple and then the index. Right? And I use the index of 0. So that gives us the very first name. So if I run this code, I will see that I have John here. Okay, so that's that about tuples and lists. Let's talk about another sequence data type, which is dictionaries. All right. So now dictionaries are different from the sequence data types we've seen so far because in dictionaries you specify the key for the values. All right. So in these data types, we can use the index to retrieve the value, right? And these indexes are predefined for us, right? But in dictionaries, we specify the index ourselves. So let's say I want to store a, a data that has the names of students and their scores. Right, I can do that this way. So I have a variable called student scores and I use a curly braces. In this case, here for list I use square brackets for tuples parentheses, but in dictionaries I use curly braces and I'll specify the name of the student to the left and the score of the student as 67, separated by comma, congruent, then back comma, faith. I have a score of 57. Right, so this is a dictionary. Right, so I'm going to print out the student score. Then I would print out the type just to verify that this is indeed a dictionary. Underscores. Now see that indeed I have a dictionary and it's of class 6, right? So this is how to create a dictionary. Right. So before I move forward, I want to mention that you can actually create this variables or these sequences using their constructors, right? So I can decide to create a list using its constructor. So what I mean by that is I decide to create a list using this. So using this constructor, and I'll pass in the values I want to pass in here. Right. So it's still going to give me exactly the same thing as this area, right? So just so that you're aware, right? I can do the same for other sequence data types as well. Okay, so now in a dictionary, as your guess is as good as mine, to retrieve the values, you need to use a key. So let's say I want to retrieve the score of student John. All I need to do is just to print out the student scores, and then inside the square bracket, I'll specify. So you can see that I have these index values here, this intelligence, and I just specify faith. And if I run the code, I'll see that this is indeed. Oh yes, I have an error there because I need to pass this into double brackets. Alright, so this is how it's supposed to be. So it has to be in double brackets. Alright, so here I can see that the score for faith is indeed 57. Okay. Alright, so let's talk about another sequence type or collection. Um, which is referred to as sets. Right. So there's something you need to know about dictionaries, which I haven't mentioned yet, and that is that a dictionary does not take in duplicate values. So you need to be aware that if I have a key of John that it says I can create another key of John, there has to be a single key of John. Right, so let's go to sets. Right. So for sets, sets are a sequence type that is used to store multiple items, as you've seen for other sequence types, and it does not take duplicates, right? So it's supposed to have unique values. For a list, you can have duplicate values, and you're going to, well, you won't have any issues. So you can see we already have duplicate values. You have 10, you have 10. This one, there are no issues, right? But for sets, let's say I have a set of numbers. Right? So for a set, you also use curly braces, and then you specify the sets. So let's try to have duplicate values, and if I print out the numbers, I print out the type, the numbers, and I run this code, I'll see that all the duplicate values has been removed automatically, and I now have this new set of values, and you can see that it's indeed a plus set, right? So another thing about sets is that they are not mutable, right? And you cannot index the values that are stored in the set, right? So just like we did for lists where they try to index the values stored there, like this, so this is like this. So if I try to run this code, I'm going to have an error because in the sets you cannot index values that are stored in it, right? So there are various methods that apply to each of these sequence types. So to access the methods stored in, let's say, set, I can do something like this. Number. So once I use this dot sign, you can see all the methods are applied there. So for instance, I can add two sets together using the add method. I can clear a set, I can copy the set to another new variable, I can pop them, I can remove, and all of that. So all of these methods are available to that particular data type using the dot So once you press it off, you can access the methods, and you can also access the properties that apply to that particular data type. Okay, so that's it about sequence type. So let's go to the next thing, which is conditional statements. All right, so now that we have an idea of how to create variables, how to store several data types, how do we make decisions using our code, right? So we make decisions using conditional statements. Okay, so let's say I want to print out a statement if something is true. I want to print out something else if something is false. All I need to do is to use the if-else statement. So there's something you need to be aware of. That is that in Python there are something referred to as reserved words. Now, when creating variables, you cannot use reserved words. For instance, print is a reserved word. Type is a reserved word. So all of these keywords have their own meaning in Python, and you cannot use them for any other thing, right? So you need to be aware of that. So let's say I have a number 7, right? And I want my computer to be able to print out that this number is less than 7 for a certain condition, and it's greater than 7 for a certain condition. So I'll use the if-else statement for that. So I'll write my if, and then I'll specify if num is less than 7, then to give the code what value to specify or what result to provide when this condition is true. All I need to do is first of all add this colon here, and then I'll go to the next line. You see that Python automatically creates this indentation for you. In Python, indentation is very, very key, right? Indentation tells Python what block of code belongs to what particular condition or one particular function, all right? So unlike other programming where you use curly braces to indicate that, in Python we use indentation. So here inside this particular indented block, I'm going to specify that I want to print out. So I'm going to use a formatted string to print out this statement. So I'll do something like this. I'll write my F here, and I'll add my apostrophes here, and I'll say, and I'll say, and I'll do something like this. So I'll use a curly brace, and I'll specify the variable name inside that curly brace, so that it will give me access to the value, right? So I don't need to encode the value. Okay, so num is less than 7, right? So here I'm just saying, okay, if you check this num value, this num variable, and the value stored in it is less than 7, just print out this result that the num, which is that variable, has a value that is less than 7, right? So these are you write conditions in Python, right? So if I run this code, you see that, okay, I need to delete this. I'm still having this error. So you can see that there's no output, and your guess is as good as mine. 7 is not less than 7, right? So if I change this value to 4 and I run it again, you see that it's now printing out that 4 is less than 7, right? So let me reiterate. This particular condition has to evaluate true for this block of code to be executed, right? So if this condition is false, this code will not be executed. Okay, now, so we've seen how to specify a specific condition. Well, in the real world, you're going to have multiple conditions that you want to check, right? And then based on those conditions, you want to make decisions, right? So to have multiple conditions, you use the elif keyword, right? So I'll write the elif keyword like this, elif, and then I'll specify the conditions I want to check. Here I want to check if num is greater than 7. Okay, and I'll have my colon, and then inside that indented block, all I want to do is to print using a formatted string. There are other ways to print out statements, but I prefer to use this. it's cleaner for me. It's greater than 7. Okay, so now we have multiple conditions, right? If I execute this, it's going to give the same result because 4 is less than 7. And something you need to know about conditions is that once a condition is true, right, and let's say you have elif here, this elif is not going to be executed at all. Python is not going to look at it at all because this elif is supposed to be like a continuation of the if. All right. If I have a if I had begun with a new if statement, then it's going to be executed. Right? Python has to check that condition. But since it's an elif and this first condition is true, Python is not going to look at this at all. Okay. So if I change this value to 10, right, and I run it again, you see that now it's spinning out this condition, this result here, which is that 10 is greater than 7, right? So what Python does is that Python checks this condition and sees that it's false, and then skips this, and then goes to this next line, checks the condition and sees that it's true, and then we have it returns this result, right? So what if this value is 7, right? So you see that we're not going to have anything because all conditions are false. So in programming, you want to always avoid scenarios where you're not catching all the conditions, right? You want your computer to be able to do something when the conditions are not true. So for that case, you use something better than else, right? So in an else, you don't need to specify any conditions, right? Because the else is like a default. So in my else, I'm just going to say, I want you to print. So I'm going to copy and paste this. Right. So I'm going to use another method, right, to write this. So just so that you're aware of the different approaches that we could take. So here I'm going to do something like this. Then I'll do a dot format, and I'll pass in here. So a format is just a method that is called on a string to kind of assign values to that string, right, dynamically, right? So there are various ways of manipulating a string, which we did not really discuss, but we can always go to learn about that later on. So this is another way of writing the same code that we wrote here, but here we're using the format and then passing the variable here. And this variable is going to be dynamically assigned to this call braces at runtime. All right. As you can see, this else is being executed because both conditions here are false. All right. So that is basically what conditional statements look like. All right. So we are going to be writing we're going to be testing out several conditions and then trying to do certain things if a condition is true or false. Okay, and there are certain things. There's another thing you need to be aware of, and that is that you can have multiple elif in your if statements, right? So this is a complete if statement, right? So once you write another if statement, be aware that you are starting a new condition entirely, right? So, but as I said earlier, you can have multiple elif statements in your code. For instance, I can say if num is less than or equal to a value, I will print out something, right? Okay. So you can have multiple elifs. So let's say you have multiple conditions that you want to check. Can you see? You can use multiple elifs before you get to the else. Okay. So that's it about conditional statements. Now, there are various types of conditions you can use. For instance, here we've seen the less than condition or the less than conditional operator. So these things are referred to as operators. So the equal sign operator, the less than operator. So these operators are referred to as conditional operators, right? But they are used to, they're going to, when you use them, they're going to return booleans, right? As you can see, this is going to return a boolean, it's going to return a boolean, and so on and so forth. So there are other conditional operators that we've not looked at. So for instance, if I want to check if something is not equal to something, all I need to do is to use the not equals operator. Let's say I want to have a variable that checks if 5 is not equals to 6, right? So this is going to return a boolean and then store that group. Okay, let me just use is 5 equal to 6. Right. So one other thing you should be aware of as a programmer, right? This applies to all kinds of programmers and also Python programmer, is that you always want to give your variable a name that reflects the value that is stored, right? Variable naming is also very, very key because your code is supposed to be something that people can read and understand, right? So this code here checks if 5 is equal to 6 and then assigns that result to this particular field. So if you print out this variable, you see that it's going to give me a boolean, right? So because 5 is not equal to 6, right? So the other conditions like if that is actually equal. So if I want to check if two things are equal, I'll use a double equal sign. In this case, I'm going to have false, right? Because 5 is not equal to 6. I can check other things as well. So this just let you know that there are other conditional conditions that you could check for when writing conditional. So let's go to something referred to as loops. So usually you want to be able to do a certain thing continuously, right, for a specified number of times. Okay, so to achieve that, you need to use something referred to as loops. And in Python, there are two loops. There are two types of loops. There's a for loop and there's a while loop. All right, so for loop and the while loop. All right, so for for loops, to write a for loop, all I need to start with a for keyword, and then I'll say, because I want to loop over. So usually you'll be looping over a sequence, right? So, and I'm going to be creating a dynamic sequence. So using range. So I'll say for x in range. So I'm going to be using the range function to create a sequence. I mean, dynamically, the range function is going to create a sequence. In this case here, specifying 9, meaning that I want a value. I want a sequence from 0 to 8. All right. So that's what that's going to give me, and that's actually going to give me a tuple. All right. So here, I'm trying to say I want to loop over this sequence, and this x here is my iterator, right? It's the value that will be changing during that sequence. So okay, I'm going to print out x. So you can see the results. So as you can see, I have this result of 0, 1, 2, up until 8, right? So you can see that it's doing that multiple times, right? So that's how loop works, right? So if I can loop over a couple of things. So let's go back here and then look over this course. So let's say I want to print out this course, right? One after the other, right? I can loop over that particular score using a for loop. So I'll print out, right? You can see. So let me just print out something else to kind of separate. Separate the different things. So you can see I have this course here. So inside this particular loop, I can do a couple of things. Like for instance, I can update the value of I using this this operator plus equal sign. All right, so I can use the plus equals operator to kind of add the value of 1 to the value of my iterator for each looping step. All right, so if I run this code, I'll see that I was able to add 1 to each, right? So you can see 3 is now 24, 34, 35. So you can manipulate the value of the iterator for each step. So here I'm using a plus equal sign operator, which is basically a shorthand for I equals 2, I plus 1, right? So there are various types of there are various shorthand writing code which you'll be seeing as you proceed. All right, so there's something else you need to learn about loops, and that is that you can actually break a loop at some point in your code. because you don't want a loop to continue to run forever, right? Certain times you want to stop that loop when a condition is met, and you want to continue that loop when a condition is met. So let's say I want to stop this loop for this range here when the condition is, that is when x is equals to 5. So I'll write the conditional statement if x equals to 5 inside that for loop block, and I'm going to say break, right? So what this is going to do is that it's going to stop this particular loop when x is equals to 5, right? So let me run this. So if I come back here, I'll see that in this loop here, right, I'm supposed to go from 0 to 9, but now I'm going from 0 to 4. It tells you that at the point when x hits 5, the loop stopped, right? It broke at that point, right? So that's what the break statement is used for, right? So it just is to cause it to stop a loop. So there's another statement referred to as the continuous statement that is used to skip that particular step, right? So let's say I want to skip this value, skip the point at which x is equals to 5. So I'm going to use continue. If I run this code, I will say that at the point when x is equals to 5, it actually skips it and then move to the next step, which is where x is equals to 6. Right? Those two statements are very key for you when writing those. Okay, so now when we discussed the range function, we really said that when you specify any value specified here, it's going to start from 0 and then end at the value before this particular value is specified. You can actually fine-tune this particular range function to output values for you that you define. So let's say I want to start from 1, right? I can say I want to start from the value of 1 to 9. So in this case, it's going to stop at value before 9, which is 8. So, and I also want to step the value by 2. So by default, the value is stepped by 1, meaning that it keeps adding 1 to the next value. So here I'm saying I want to increase that to 2. So if I check, I'll see that here I have 1, which is the first value. It adds 2. I have 3, which is the second value. It adds, it skips this value of 5. So I want to remove this function statement. I'm going to run this again. Okay, so now I've moved that particular statement. Now, if I run this code, you see that it's actually adding 2 for each step. Previously, it was adding 1, but now it's adding 2 for each step. And then when it goes to 7 and I added 2, notice that it has passed the maximum for that range. Because here, this is a minimum, this is a maximum, this is a step. All right. So that's it about for loop. Let's talk about the next type of loop, which is a while loop. So in while loop, you have to specify a start condition for your while loop. So in while loop, you have to specify that this is where you want to start from, right? So here I'm going to say I want to start from the value of 1, and I'll use my while keyword. I'll specify that. So in while loop, you write it like this. So as you can see, I'm writing while I, which is our start value, is less than 10. Print out I. Then I'm going to update the value of I using this operator, plus equals operator. So it's going to add a value of 1 to that value. It's for each step. So if you check this condition, is I less than 10? Yes, print out the value of I, update it by using this plus equals operator. Now I is equals to 2, goes back again and checks it's 2 less than 10, and it continues until this condition is false. So that's how the while operator works. Run this code, I'll see that I have this. So I'm going to print out just to separate things. So you can see I have 1 up until 9, because at the point when the I value is now 10, this condition is already false, so it stops that execution, right? So you always want to make sure that you do not forget to add this updates line of code for while loops, because if you don't, your loop will continue to execute and your computer can crash. And so loops are very, very dangerous in some scenario. You always want to make sure that you exit out of your loop that you started. Right. So that's it about while loops. So every other thing that applies to for loops also applies to while loops, right? And you can loop over a couple of things. You can loop over strings. Let's say you want to manipulate a string. You can loop over a string. You can loop over a tuple. You can loop over a dictionary, and so on and so forth. So the idea here is to show you how to actually write the code for that looping. Right. So finally, let's talk about functions. Right. This is actually the sweetest part for Python codes and for any coding generally, because functions are like the life of your program, right? So what are functions? So functions basically give you the power to reuse code, right? You don't want to keep writing the same code over and over and over again. Right? So you want to encapsulate that particular block of code and then be able to use it anywhere else in your program. So that's what functions give you the power to do. So let's say I want to write a code that will be able to add two numbers together, right? So, or basically just print out something on the screen. So I can write a function for that. Here I'm going to define a function using the def keyword. So in Python, the def keyword is used to define the function, and I'll give the function a name. In this case, the function is going to just print out a name, and I'll add a parenthesis to that function name, and then click my colon, and then go to the next line. Right. Remember I said Python indentation is very key. So here this indentation means that this code that I write here now belongs to that function. So here I just want to just print out something. Yeah, this is a function. So now if I run this code here, nothing is going to happen because I only define this function. So this is a function definition. Right. To actually use a function, you need to call that function, right? So to call the function, I will just write the name of the function like this, and that is going to just basically call that function. In this case, this is my result. This is a function. Okay, so this is defining a function and calling a function. Now, before I proceed on to discuss other things about functions, I want to talk about something better, the scope of the variable. So let's say I have a variable defined as x here, and here I want to print out the value of x inside my function, right? So if I run this code, you see that I'm indeed getting the value of x. So let me just separate this here by writing a print statement with several lines. So you can see that I have this 10 value, this 10 as the output of my function, right? So because this variable here can be accessed by this function. Now this variable that has access everywhere in my code, because I can also print the variable here too as well, and I'll have 10 as well. As you can see, I have 10 here, I have 10 because this variable has something referred to as the global scope, right? So this is the variable scope I talked about earlier, right? But if I define a function a variable inside function, right? Let's say I define a variable y equals to 6, and I'm printing out y here, right? So if I try to access that variable outside of that function, and I run this code, so you can see I'm already getting the irregular lines already. See that I have an error because I have a name error because y is not defined. Okay, so what that means is that this y cannot be accessed outside of this function scope, right? So that means this y has a function scope. So you could also say that it has a local scope because it's defined inside a particular block of code and can only be accessed inside that block. All right, so that's it about scope. Let's go back to our functions. So in this function here, I'm not doing something interesting. I'm just basically printing out the result. So I want to define a new function that basically multiplies two numbers. Okay, so I'll call that function multiply. Now, in functions, you can assign parameters. So since I want to multiply two numbers, I'm going to pass in parameters num1 and num2, and then I'll basically use the return statement to return the result of the two values, the result of the multiplication of two values. So this is what it's going to look like. All right. So here, unlike the first function that we created, here I'm having something referred to as the parameters to the function. And the parameters basically gives power to your function because when I call the function, I can pass in multiple arguments to that function. Let's say I want to multiply 5 and 6, I can just pass in 5 and 6. I want to multiply 6 and 7, I can pass in 6 and 7. So basically, this is basically a definition of that function. So here, and I'm also using return here to basically store that result in that function, right? It's more useful than using the print statement. Okay, all right. So if I call this function multiply, you see that I'm having this stuff. If I run this function without doing anything, I'm going to have an error because, okay, let me cancel this first. I'm going to have an error because multiply is supposed to take two positional arguments, right? Num1 and num2, because in my function definition, I specify that num1 and num2 are parameters to this function or inputs to this function. So here, if I specify 4 and 5, I'll see that my result is going to be 10. I mean, my result is there's no result actually, right? Because whenever I use the return, the value of that, the result stored inside the result is stored inside a function. So you need to actually set a variable to that function, right? Like this, and then print out the result. But this is how you're going to see the result of the function. So you can see now I have my 20 here, right? Because 4 times 5 is 20. So I could change these parameters any way I want to, and I'll have a different result. I can call this function in a new script. I can do whatever I want to do with this function, and I will be fine because functions are reusable, and that's the power that we have when we create functions. All right. So you can decide to create any function that you want to create by using all of the knowledge you've learned about the basics of Python programming. Right. So this brings us to the end of this Python course for absolute beginners. I hope you're able to learn to get some value in this course. I hope you come back later for more content like this. See you and